Hey kiddos, today we're going to be discussing angles of polygons. So we are kind of in a sense leaving the triangle world, but we're going to be talking about a lot more different types of shapes. So consecutive vertices are two vertices that are endpoints at the same side. A diagonal is a segment in a polygon that joins two non-consecutive vertices. The diagonals from one vertex divide a polygon into triangles, as you can see here. Dividing a polygon with n sides, so we don't know the number of sides it has, into n minus 2 triangles shows that the sum of the measures of the interior angles of a polygon is a multiple of 180, because triangles are 180 degrees. So in polygon ABCDE, A and B are consecutive vertices. Okay, vertex B has two diagonals, which are BD and BE. Polygon interior angle theorem. A polygon is convex when no line that contains a side of the polygon contains a point in the interior of the polygon. We'll go in a little bit more detail with that a little bit later. The sum of the measures of the interior angle of a convex n-gon meaning we don't know how many sides it has, is this formula here, where it is the number of sides subtracted by 2 and then that value multiplied by 180 degrees. So here we can tell that it has 1, 2, 3, 4, 5, 6. So it has 6 sides. So to figure out what the sum of the measures of the interior angles would be, you would plug that into 6 minus 2 times 180. 6 minus 2 is 4 times 180. And 4 times 180 is 720 degrees. So the sum of the interior would be 720 degrees. Now the corollary to I don't even know if I'm saying that word right, so sorry. Yeah. To the polygon interior angle theorem is basically the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Why is it 360 degrees? Well, quadrilateral we know has 4 sides. So in drawing that diagonal, there's 2 triangles. 180, 180 makes it 360. Or if you plugged it into that formula right here, you would also get that same value. All right, so moving on to some more vocabulary. An equilateral polygon is a polygon where all sides are congruent. Equiangular polygon is when all the angles in the interior of the polygon are congruent. Okay. A regular polygon, so this one is very, very, very important. Okay. A regular polygon is a convex polygon that is both equilateral and equiangular. Okay. Very important that you know regular. Okay. Now, the polygon exterior angles theorem basically states that the sum of the exterior angle measures does not depend on the number of sides of the polygon. So how many sides it has is irrelevant. Okay. The sum of the measures of the exterior angles of a convex polygon is always and forever going to be 360 degrees. All right, so classifying polygons. Polygons are named by the number of sides they have. Since polygons come in many different shapes, you can classify them simply to simplify their description. All right, so remember, polygons that have all sides and all angles congruent are regular polygons. So here is a table classifying the most basic ones. So you have a triangle, which is 3-sided, quadrilaterals 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, decagon 10, undecagon would be 11, dodecagon is 12, and then if you don't know the number of sides, we just call it a n-gon. Now let's talk about concave and convex. So polygons can be either concave or convex. You kind of already hit on what convex looks like. The easiest to explain the difference is basically by drawing a circle. If a circle is drawn around the polygon and all of its vertices, okay, are on the circle, then it's simply convex. So if just one of the vertices, that's all it takes, just one vertice to not be on the circle, then that polygon is off, so is concave. I like to say that those vertices are basically like caved in, to think about it. So if you notice here, this vertice here is caved in, so that's why this one is concave. This one here, all the vertices actually would touch the circle, so therefore this one is a convex polygon. So here we're going to determine whether the following polygons are convex or concave. So remember, the nice helpful hint here is drawing a circle to the best of your ability. So don't laugh at my horrific circles. Hee hee hee. All right, so remember, if the vertices all touch the outside of your circle, then it is convex. Notice here, this vertice does not touch my circle. It's caved in, so it's concave. Again, here, this part right here is caved in, so therefore it is concave. And this is all touching the outside of my circle, so therefore this one is convex. All right, here we have a wonderful table that you guys are going to fill in, because I know you are all more than capable of doing this. I'll do a few of them with you guys just to get you to get the hang going, and then I expect you guys to finish it. Now, polygon names, kind of went over it on a few slides before. So n-gon is when we don't know the number of sides. So the number size here is n. The total interior sum was that formula that we talked about, n minus 2 times 180. Now, let's say if it's a regular polygon and I want to know what's just one of the angles on the inside, then this is the formula that you would follow, which is basically n minus 2 times 180 divided by n. Then the total exterior, so exterior is the outside sum, is always and forever for every single one of these. It's always going to be 360 degrees. Remember, we talked about that earlier. It doesn't matter how many sides it has. The exterior for every polygon is always 360 degrees. But if it's a regular polygon and we want to know what's just one of those exterior angles, then all you have to do is simply take 360 and divide it by n, the number of sides it has. So if we were to plug this in for a triangle, you would have 3 minus 2 times 180. And 3 minus 2 is 1. 1 times 180 is 180 degrees. You already knew that, though. So if I wanted to look for one of those angles, well, no need of me redoing this math because I just did it, and that applies here. So you would have then simply 180 divided by 3, which equals 60. And you know that's true because that's our equilateral triangle, which is also equal angular, which is important if it's going to be a regular polygon. And then to figure out the one of the exterior sides, we take 360 degrees and we divide it by 3, and you would get, so 360 degrees divided by 3 results in the exterior would be 120 degrees of a regular triangle. All right, let's do one more together. So we have here the quadrilateral. I'm not going to be able to fit it all in there, but you can spell it quadrilateral, and quadrilaterals have 4 sides. So let's figure out their total sum. That would be 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360 degrees. So quadrilateral's total interior sum is 360 degrees. Now, if it is a regular quadrilateral, then one of the interior angles would be simply 360 degrees divided by 4, which results in 90 degrees. All right, we already know the total exterior sum is always 360. So let's go to, if we have a regular quadrilateral, and I want to know what's just one of the exterior angles, we would simply take 360 degrees and divide that by the number of sides, which is 4. So 360 divided by 4 is 90. So notice this one's a little special. The interior and the exterior of a regular quadrilateral would actually be the same. I want you guys to take the time now to complete the rest of these. I will give you this hint. This is an undecagon. All right, so here's just more practice utilizing what we know. First thing here is finding the sum of the measures of the interior angles of a figure. So what we have to know is how many sides it has. This has 1, 2, 3, 4, 5, 6, 7, 8 sides. So it has 8 sides. I know the formula is n minus 2 times 180. So if we plug this in, you have 8 minus 2 times 180. 8 take away 2 is 6. 6 times 180. 6 times 180 results in 1,080 degrees would be the total interior for that one. All right, let's look at example 2. The coin shown is in the shape of 11 gon. So find the sum of the measures of the interior angle. Show all work. All right, same concept. So they already told us how many sides it has, so I don't have to sit here and try and count them all, okay? They already told me it's 11. So plug it into our formula, 11 minus 2 times 180. And technically, you guys, if you completed the table as I asked, you guys would probably already have all these answers. 1,620 degrees would be the total interior sum for an 11 gon or undecagon. All right, so the sum of the measures of the interior angles of a convex polygon is 900. All right, so they kind of switched this up on us. So now we're given the sum of the measure, and they want us to figure out how many sides it has. So n minus 2 times 180 equals 900. All right, so we're going to do some math here, some algebra. Divide both sides by 180. All right, I get n minus 2 then equals 5. Gonna solve for n, so I'm gonna add 2, n is equal to 7. So if it's 7, the name of that is a heptagon. Some people also, I believe, like to call them septagons, but we're gonna go with heptagon. All right, taking it a little bit a level up. Finding an unknown interior angle measure, find the value of x in the diagram below. Now, the very first thing that you have to make sure that you know is what is the interior sum supposed to equal for this specific polygon, which means you need to know what type of polygon it is. This has 1, 2, 3, 4 sides, which means I know it's a quadrilateral. And if I refer back to my table, I know quadrilaterals have an interior sum of 360 degrees. So in order for me to figure this answer out, I'm going to add the 3 degrees they did give us, and we're going to subtract that answer from 360 to figure out this last one. So 108 plus 121 plus 59. When I add those 3 up, I get 288. Now, I just need to subtract that from 360. So 360 minus the 288, and I'm left with 72. So therefore, this value here has to be 72 degrees because a quadrilateral's interior sum is 360. All right, example 5. The sum of the measures of the interior angles of a convex polygon is 1,440. Classify the polygon by the number of sides. Show all work. So again, we're kind of working backwards here. And this is where our handy-dandy formula helps out. Equals 1,440. All right, so algebra is awesome because we can work this out algebraically. And divide both sides by 180. You get n minus 2 equals 1440 divided by 180 is 8. Then I'm going to add 2 to both sides. N is equal to 10. And that is called a decagon. All right, example 6. The measures of the interior angles of a quadrilateral. So I'm just going to draw a quadrilateral and yeah, okay, so there it is, 4 sides. And angle 1 is x degrees, angle 2 is 3x degrees, angle 3 is 5x degrees, and angle 4 is 7x degrees. Draw and label the quadrilateral, find the measures of all the interior angles. Okay, so very important. This has got 4 sides, which tells me that the total sum is 360 degrees. So to figure out what the value of x is, to be able to plug it all in and figure out all these sides, we just need to add them all up and make them equal to 360. So x plus 3x plus 5x plus 7x equals 360. Combine all my like terms, so that's 1 plus 3 plus 5 plus 7, and that gives me a total of 16x equals, 360. Gonna divide 360 by 16, and x equals 22.5. All right, so we got here the x is 22.5. Well, the measurement of angle 1 is x, so measurement of angle 1 is 22.5 degrees. Angle 2 is the 3x. So if I take 22.5 and multiply by 3, we get 67.5 degrees. To find the measurement of angle 3, which is the 5x, now I got to take 5 times the 22.5, and that gives me 112.5 degrees. And the last one was 7x, so that's 7 times the 22.5, and that gives me a total of 157.5 degrees. Now, if we're not sure if that sounds right, if we take 22.5 plus 67.5 plus 112.5 plus 157.5, and I add it all up, it better be 360, and it is, so check, voila. All right, finding angle measures and polygons. A home plate for a baseball field is shown. So shout out to my baseball peoples. Okay, is this polygon regular? Explain your reasoning. Now, I see it's got 3 angles that are the same, but then these 2 angles are different from A, B, and D. So therefore, this is a no reasoning. It's not equiangular. Remember, to be regular, you have to be equal angular and equilateral. So, B, find the measures of CE, show all work. Now, we know because of these markings, these are 90, that's 90, that's 90. We know that angle E and angle C are going to be congruent. Now, this is 1, 2, 3, 4, 5-sided figure. So if I look back at my table, a 5-sided figure has a total of how many degrees for its sum? So when you plug it into that formula, or if you look back at our table, because you already did all that work, it's 540 degrees is the total measurement for all the angles on the inside. So what we're going to do is we're going to take 540, and we're going to subtract 90, subtract the other 90, and subtract the other 90. So what we're left with is 270 degrees. So if I'm left with 270 degrees, and I know that E and C are the same, I can take that 270 degrees, and I can divide it by 2, and I get 135. So therefore, I know this is 90, I know that is 90, I know that is 90, so therefore E is 135 and C is 135. If I add all those values up, they should equal 540. So C and E are 135 degrees. All right, so moving on to the next problem. The question is first, is polygon A, B, C, D, E, F, G regular first, and then after that, figure out what is the measurement of angle B, D, E, and G based on what is given. So this is going to be an OYO problem, so handle it. All right, finding an unknown exterior angle. Now, find the value of x in the diagram and show all of our work. Whoops. So remember here, the total exterior angle measurement of any polygon, no matter what it is always going to be 360 degrees. So all we have to do here is add all those up, 2x plus 89 plus 67 plus x, and just simply make it equal to 360. So combine my like terms, we get 3x plus 156 equals 360. All right, let's do our algebra. We're going to subtract 156 to both sides. Those cancel out. 3x equals 360 minus 156. 204. Last step, divide by 3 to get x by itself. So 204 divided by 3 is that x equals 68. So x is 68. And that's all they really wanted us to do for this problem. So that's 68. But if I wanted to go to a step further, figure out what was the 2x would be, that would actually be 136 degrees. All right, next example. Finding angle measures in regular polygons. A trampoline shown is shaped like a regular dodecagon. So that's a 12-sided figure. Okay. Show all work. Find the measure of each interior angle. Well, remember the formula here is n minus 2 times 180 all divided by n. Okay. For the exterior angle for B, it's simply just 360 divided by n. All right, so those are the formulas that we need to answer this question. So when I plug it into this formula, we get 12 minus 2 times 180 divided by 12. So that leads us to get 10 times 180 divided by 12. So 10 times 180 is 1,800, and that divided by 12 is 150. So 150 degrees is one of the interior angles if this is a regular figure, which it is because they tell us. So B, the exterior, simply is going to be 360 divided by the number of sides, which is 12. So 360 divided by 12, because this is a dodecagon. And the answer is each exterior angle is just 30 degrees. All right, now let's move on to the next example. A convex hexagon has exterior angles with the measures of 34, 49, 58, 67, 75. What is the measure of an exterior angle at the sixth vertex? Show all work. So let's go ahead and draw a figure that would look like this, but just to get the visual of it. All right, so as you can see, I went ahead and drew it out. So this is our hexagon, 6 sides, and then those are the exterior angles, and this is the one that we're looking for. So all we have to do is set them all, add them all up, and I included the plus x because that's the sixth one that we're looking for, and make them equal to 360 degrees because that's what's the total sum always going to be for any polygon. Okay, so you get 283 plus x equals 360. So 360 minus the 283 leaves us with an answer of 77 degrees would be the value of x. Word. Whew. Hopefully, you guys don't find this too difficult. Adios. Ciao.